Hello Year 7, this is your next lesson in your shifting states topic. This lesson we're going to look at water conservation and you are going to start a project that's going to run over the next 2 weeks. My name's Mrs. Chiverton, I'm one of the science directors and I'll be guiding you through this lesson today. So before we start, you need a printed off version of the water conservation booklet, which is in this same folder. And you need access to the internet in order to complete some research. You'll also need your normal exercise book, pen, pencil and ruler, or some paper to work on, as there are activities to do as we work through the PowerPoint. If you need to collect any of those things, please go and collect them now. Pause the video while you do so. In addition, you also need to make sure that you switch off the volume, etc. on any other devices other than the one you're using to view this video. So just to get us thinking and reflecting back on what we did last lesson, what I want you to do in your exercise book or on your piece of paper is write down as many issues as you can think of that might occur if this child was to drink the water that you can see them collecting in the photograph. So what problems might it cause for that child? I'm going to give you a minute and a half in order to think of those ideas. Okay, so you've probably thought that water looks dirty and therefore might have chemicals in it that could cause the child to become ill, or it might have bacteria in it that may cause the child to become ill. It's obviously dirty looking at it. It hasn't come from a clean source. You can see rubbish and so on around it. There may be animal waste in there, there may be human waste in there, all of which potentially could make that child ill. And many children die of such issues in the world every day. So in terms of our learning journey through shifting states, we're now going to be looking at how we can be more responsible with our water. So our challenge today is to be able to justify the need for potable water and explain the issues that some countries face. And our aspire is to be able to create a campaign to support the conservation of water and design some solutions for the issues some countries face obtaining potable water. Now that second learning outcome will be also continued into next week. So our starter today is what you can think about what I've already said about drinking dirty water. And I want you to explain why it might be dangerous to drink dirty water. I'm going to give you a minute and a half to jot down as many ideas as you can as to why it might be dangerous to drink that dirty water. Okay, hopefully you've got some good ideas written down there. The key points that you need to be thinking about when we think about the dangers of drinking dirty water is that dirty water may contain any of these things: toxic chemicals, which could be poisonous and make you ill or actually kill you; too many dissolved minerals, which again can lead to illnesses and ultimately, if not treated, can cause death; and finally, high levels of bacteria. And if those bacteria cause specific diseases, again, you can become very ill as a result of drinking that dirty water and possibly die. So they could all make you ill or possibly kill you. So in the UK, when we turn on our taps, we naturally assume that the water is safe to drink, and in most of the time it actually is. And that's because it's treated before it's supplied to our home. But some people don't have that privilege. Where might people have to get water from if it doesn't simply come out of a tap? You've got about a minute to write down any sources of water, particularly in countries where there is limited tap water available. So unfortunately for many people, water from a tap is not available. And what we've got are some images here that show some of the things that people have to go through in order to get water for their everyday living. So many people in many countries still have to walk several miles a day in order to collect water from a relatively safe source of water. And even those sources of water that they collect from, like the pump shown on the right hand side, the water may not be potable quality water and therefore may not be completely safe to drink. So this is something you may have thought about or seen before. We've got 2 glasses of water there, and what I want you to do is to explain to me which of these glasses of water is safe to drink. I'm going to give you 2 minutes to think about, record your answer, and then explain why you've made that decision. Now, I gave you quite a long time to think about what might seem like a very simple question there, but that's actually because I really wanted you to think deeply about it. And I suspect that many of you have plumped it for the glass of water on the right and decided that because that's clear and isn't obviously dirty, that it's probably safe to drink. But I also think a few of you might have had some doubts about that. Yeah, and how can we be absolutely sure that that water is safe to drink? When we talk about potable water, we can't tell just by looking at it whether or not it's safe to drink. In some areas of the world, we have lots of clean, fresh potable water. But in other areas, it may be salty or the water may have been contaminated with chemicals, dirt or sewage, and this would not be potable and it would make us actually ill. And you cannot always see those contaminants in the water. In addition, of course, if it's got a high bacterial count, that would also make it not potable for us. We wouldn't be able to drink it safely. And I think this is an astonishing fact. Every 15 seconds, a child dies from water-related diseases. That's 4 deaths every minute. So there's a timer going at the top of this slide. One child's already died. That's child number 2. Child number 3. Child number 4. And most of those deaths are actually preventable if we can get those children potable water. So imagine you had to drink this. It might be contaminated, it might make you very ill. So what could we do to clean this water and make it potable and safe to drink? So, would filtering the water remove all of the contaminants? Because that was one of the main ways we can clean water in our country. What might be in this water that we can't actually see? And the clue is the little guy at the bottom with his magnifying glass, although actually we'd need a microscope to see what else is in there. And what we might be able to see is examples like this. This one is actually examples of a typhoid bacteria, not something that you would particularly want to eat and would make you extremely ill in high numbers in your body. So waterborne diseases are caused by consuming contaminated water, and these diseases include things like cholera, typhoid, dysentery, E. coli, hepatitis A, and they're all caused by microorganisms in the water that we cannot see with just our eyes. They're very, very rare in the UK, but in many other countries of the world, these diseases are very prevalent. That means lots and lots of people catch these diseases on a daily basis. And they will all lead to symptoms like severe vomiting, severe diarrhea. That results in dehydration, where our bodies simply don't have enough water in them, and ultimately this can lead to death. Now, they can be treated with things like antibiotics and rehydration, but it isn't always successful, and they can be very, very debilitating diseases. Salt water accounts for more than 97% of water on the earth. So why don't we drink seawater? That would seem a logical solution to our lack of healthy water. The problem with seawater is that it contains very high levels of dissolved salt. Now, our human kidneys, which are responsible for making urine, so we can go to the toilet and get rid of waste products from our body, can only make that urine if it's less salty than salt water. So to get rid of all the excess salt taken in by drinking seawater, we would have to urinate more water than we drank. And the problem with that is that we would become dehydrated and even thirstier as you went along. And eventually that would result in death. So less than 1% of the world's fresh water is actually readily accessible for direct human use. And everything else has to be treated in some way in order to make it safe for us to actually drink. So we found lots of different sources of water to produce potable water. We can use reservoirs, which is fresh or groundwater, where it's actually on the surface of the water and has low levels of salt. We can treat wastewater, so water that's come from our toilets and our waste systems in our houses and in our factories. We can process that water and make it safe to drink. And we can actually produce potable water from salt water as well by removing the salt. So this table is going to allow you to summarise the different types of water treatments and come up with some advantages and some disadvantages of it. And what I'm going to do is I'm going to give you 60 seconds to record that table in your book or on your paper, and then I'm going to give you some information that you will then include in that. So you should have got that information down, that table drawn out. If you need a little bit more time, just pause the video and you can finish doing that. So let's give you the information to fill in that table. Feel free to fill it in as I go along, but I will put up a summary at the end as well so that you can self-assess and improve any answers that you've done. So when we look at salt water, it has to have the salt removed from it in order to make it potable. And you will recognise this equipment from experiments that you have seen earlier on. This is the process of distillation. Now, in distillation, what we do is we heat up our salt water, and because it has a lower boiling point than the salt, the water evaporates and leaves the salt behind in the round bottom flask. That water vapour then travels through the condenser, which cools it down and turns it back into liquid water, which drips out at the end. It also means that it is microbe free and it's ready to drink as well. So this is one way of doing it. Now, the advantages of that is you do get pure water, and it's a one-stage process. The disadvantages of that are that it takes lots of energy, so therefore it's expensive to do. It needs specialised equipment, which is also expensive to do, and it can only be used for small quantities of water. So it wouldn't be ideal to supply the water for a big city, for example. Now, groundwater is sometimes called fresh water, and it comes from lakes, rivers, reservoirs and aquifers. An aquifer is simply some water that actually lives underground. And it's a two-stage process. So first of all, we have a mesh to remove any big floating bits in it, and then it's filtered more finely using sand and gravel. And then the final stage is sterilisation. So the filtration, it's a big wire mesh which separates out any large twigs, and then sand and gravel bed will filter out any of the remaining solid particles. And then the sterilisation is done to kill those harmful bacteria that we've mentioned previously. And it's done by bubbling chlorine gas through it or using ozone or ultraviolet light. Now again, the advantages are that can be done on a very large scale. It doesn't need huge amounts of equipment, and it's only a two-stage process, so it's a simple process to do. The disadvantages occur in that some areas simply don't have enough groundwater available in order to do this process, so it isn't suitable for everywhere in the world. Now, wastewater. This comes from sewage, that's the stuff that comes out of your toilet, your bath or your washing up bowls, and also from agriculture, which would contain things like animal waste and potentially chemical fertilisers. For this reason, it's a more complex process that is needed to turn that into potable water. So the first stage is similar to that for groundwater. There is a screening process with big metal grids that will really remove large bits of material like twigs and grass and anything that has come down your waste pipes that shouldn't be there, like nappies and so on. It then goes into huge tanks called sedimentation tanks, and it's allowed to settle. And the large solids, because of gravity, sink to the bottom, and the less dense solids sink to the top and can be skimmed off. And what we're left with is the liquid water in between. That liquid water can then be sterilised to kill off any harmful bacteria or microbes. And again, this can be done using chlorine or ozone or ultraviolet light. Now, the advantages of that is it can be used anywhere where we have got a population living, because we will produce that sewage and the runoff from agriculture and so on. So if there isn't enough of a supply of groundwater, then wastewater purification can be really important. It also means that contaminated water isn't just going back into lakes and rivers and the environment as well. So it doesn't only help people, it also helps the environment. So those are advantages of it. The disadvantages are that it takes a little bit longer because there are more stages in the process, and there's more specialist equipment needed in order to produce potable water from wastewater, which makes it a little bit more expensive. So I'm going to give you 3 minutes to add in any extra information that you think you need to summarise the treatment and to look at the advantages and the disadvantages of each of those types of water treatment. Okay, so hopefully you've managed to get some ideas down there. I'm just going to pop up a slide, here we go, so you can assess and improve everything. So with salt water, we're distilling it. Our advantage is the source of water where there's little rainfall or wastewater, but it's expensive due to the energy costs and equipment, and things can only be made in small amounts. Groundwater, the two main areas are filtration and sterilisation. We know it's cheap, easy, quick, and can be used in large quantities. Not all areas have enough sources of groundwater. Then the wastewater, we know the three main stages of screening, sedimentation and sterilisation. The advantages is there's good supply wherever there are people. The disadvantages, there are more stages needed, so it takes longer and as a result is more expensive. So again, just make sure you've got all of those ideas down and amend any of your answers if you need to include more detail or to change anything that you got a little bit muddled on. So let's just apply some of that knowledge. Okay, this is our stretch and challenge, so we're looking forward towards our GCSEs. We can survive for weeks without food, but only a few days without water. What I'd like you to do is explain how this work person might be able to get some potable water whilst in the desert. And I'm going to give you a couple of minutes to just jot some ideas down. You could do this as diagrams or as a written piece of work in your exercise book. You might have to think a little bit creatively about what equipment he might have with him available in order to do this. Great. Well, I hope you've come up with some creative ideas here. The kind of things that I think you may have thought of are things like our solar well still. Now, this works because it can be used to collect water and moisture from the environment. So all you would need here is a plastic tarpaulin and a load of drinking straws, something to put his clean water in and something to put his contaminated water in, and then a weight. Fresh cut leaves if you can find them in the desert. Okay, and what happens is the heat of the sun evaporates water from the leaves and from the contaminated water and from any moisture that was already there in the ground. It then condenses on the tarpaulin that you've got above, and then it drains down, and because you've got a weight holding the tarpaulin slightly downwards in that centre, it drips down into that clear water collection place. So that would be if you didn't have any access to anything as a fuel. The other alternative is that he could boil the contaminated water over a fire and collect the steam on some kind of shiny surface like a mirror, where it'll condense and give you pure water. So this is another example of what he could actually do there. So you can see him boiling the contaminated water, which would also help to kill any microbes. the water vapour would collect on that glass and then drip down into a container that he could then drink from. So hopefully you managed to get some of those ideas in order to solve that problem. So besides drinking, what do we use potable water for in most European countries? We get it piped into our homes and we use it for all sorts of things besides actually drinking. So you've got a minute to jot down as many ideas as you can think of about other uses of water in our homes. Well done. Now these are the ideas I came up with, and you may have come up with some more. But we certainly use a lot of water in our cooking. We use it in other food preparation to wash food, etc. We use it for washing clothes, washing cars, washing crockery and cutlery, especially in things like dishwashers. We use it for flushing our toilets, and we use it for watering our gardens. A lot of those uses of water don't actually need potable quality water in order to do them. And in Europe, we waste huge amounts of potable water every day with many of those activities. This water has taken time and resources and energy to produce, no matter what its source is. Conserving potable water is now extremely important in many areas of the world. What I want you to do is look at the 4 pictures that are there in front of me, and I want you to explain how they waste water and how we could change things to work to conserve potable water. So what just different thing could be done to ensure that these situations the water is conserved rather than wasted? Okay, so you've got a minute to actually get this table down. This is going to allow you to record what is being said about those individual images that you saw. So there was a picture of somebody with a tap running whilst they were still brushing their teeth. There was another picture where somebody was only putting one item, a pair of jeans, into a washing machine. There was another one where a tap was dripping even though it had been switched off. And finally, there was an example of using a hose pipe to water your garden. So when you've got your table completed, what we're going to do is look at some ways that wastes potable water and some possible solutions to get around that, which would allow us to conserve potable water. Just a few more seconds and you should have the draft of that table in your books. Okay, so that tap running while we're brushing our teeth, that's obviously a straightforward problem because the water just simply goes down the drain and would then have to be purified again before it's transferred to somebody else's house. So the easiest solution is to simply switch off the tap while you're actually brushing your teeth and only switch it on again when you need to rinse. Only putting one item in a washing machine means that the machine will have to be used far more frequently in order to get through all of your washing. So that will use far more water. And again, easy solution, only put the washing machine on when you've actually got a full load. Taps dripping even when they've been switched off, again, if it just drips, it's either going to go down the drain or soak into the ground around it if it's an outside tap. So again, mend the tap, a simple solution, often just a washer would be sufficient. And then using a hose to water the garden. This is a very, very common use of potable water from our water in our taps inside. Lots of the water just soaks into the ground and doesn't end up being used by the actual plants that you are trying to water. So the simple solution to that is to collect rainwater in a rainwater butt and actually use that for watering the plants. You could also use a watering can, and then you're a little bit more precise as to where that water actually goes. So those are the kind of things that we can think about conserving water in this country, where we do actually have a plentiful supply of it and most times of the year. So there we go, we switch our tap off, we mend our pipe, we put a full load in, and we get our water butt there. So there's our answers again, if you needed them for any more time. Okay, so now we're going to move on to a project that's going to start this lesson and you're going to finish it off in the next week's session. So this is about making an impact and it's called our water conservation project. And at this point you will need a printed off version of the booklet, which is seen in the picture there. So on average, a European resident will use about 50 gallons of water per day. That's covering all of those things we talked about earlier. Whereas on average, a resident of sub-Saharan Africa will maybe only use 2 to 5 gallons of water per day. And what I want you to do is to think about this and justify your answer. I'm only going to give you a minute to think about it. Okay. So when we look at the kind of usage that we make of our water, in domestic UK use, you can see that only a very small percentage of it actually is needed to be potable water level. So we need clean water for baths and showers because we don't want to be contaminated with microbes. Dishwashers we need again to be potable water standards, and drinking water straight from the tap we need to be potable water standards. But a lot of the other uses that we make common use of water could actually be different sources of water that don't need to be quite so clean in order to be used. So about 2/3 we reckon, and nearly half of what we use is simply for flushing toilets and washing clothes. And we don't need to use all of that fresh water in order to do that. If we look in Africa, most of the population still has to collect that potable water from wells and from water pipes, and sometimes walking many miles every day in order to do that. So they are far less inclined to waste any water that is available to them. They often also don't have flushable toilets or washing machines, so they don't tend to waste their precious water in the same way as we do. So early on, you learnt about the importance of potable water and the issues that some countries face. And now it's up to you to try to make a difference. What you are going to do over the next 2 sessions is you're going to research ways to obtain potable water and more ways to conserve water. You're going to design a campaign to encourage people to conserve water, and you're going to design some kind of product that would help to produce potable water or to conserve water. Now, in reality, a team of people would work on a project like this, and the team roles would include various things such as a research consultant responsible for overseeing the research and making sure the key findings are recorded, a communications officer who would be responsible for overseeing communication with different target audiences, and a campaign manager responsible for coordinating and running the campaign, and finally a product developer who would be responsible for overseeing the development of products that meet certain standards and criteria. And they would often be part of bigger teams in doing those particular roles. So we're going to start off with you acting as the research consultant, and you're going to get an experience of each one of these key roles. So you're going to split the task into 2, and you are going to research ways to obtain potable water and ways to conserve water. And both tasks should be completed on the mind map on page 1 to help you get started on your research. Now at this point you need to access the internet, and you need to look up some different ideas and different ways, as well as some of the ones that we've already talked about in our 2 lessons about water. So this will be a good time to pause the video and to go away and do some research and record those things. Once you've done your research, then you will need to pick one method to get potable water and one innovative method to conserve water, and get some more detailed research on those 2 methods. You can sketch diagrams and plans, and you can think of advantages and any disadvantages of your chosen method. And those tasks should be completed in the tables on page 2 and page 3 of the booklet. And they will be the basis of your campaign to get people to conserve water. Now, the key learning points that you should have got from this lesson are the following. Sources of potable water are groundwater, wastewater and seawater. Groundwater is made potable by filtering and sterilisation. Wastewater processed by screening, sedimentation and sterilisation. Seawater is distilled to make it safe to drink, but it's expensive. All water processing needs equipment and energy, and potable water is scarce in many areas of the world and needs to be conserved. And you can add this summary to your notes. Okay, that's the end of today's lesson in terms of the formal video. What you will need to do now is to complete the Google quiz that accompanies this video, and the quiz will be automatically marked and it will give you the correct answers if you are unfortunately getting any of them wrong. What you then need to do is to go and complete the tasks that are in your water conservation project about the research methods of conserving water and making potable water. Thank you for listening today.